Have you ever thought why the universe is so dark? On average, there are 225 billion large galaxies, 7 trillion dwarf galaxies, and 30 billion times a trillion stars in just observable universe. Considering that even our single star, the sun, can make our planet brilliantly bright during the day. So, how is the universe can be still so dark? More importantly, why does the universe seems pitch black to us? Does the universe have any color at all? These are truly interesting questions because they are offering us fascinating insights into the nature of the universe, light and color. We can answer these questions in two different ways. The first is from the perspective of a cosmological paradox known as Olbers Paradox, and the second is from the standpoint of the physics of light. In this video, let's focus on Olbers Paradox and take a closer look at this fascinating problem. One of these questions that puzzled many astronomers, from Johannes Kepler to Edmund Halley, was this: why is the universe pitch black instead of being filled with light? Because if the universe were infinite in size, as it was once believed, then it should contain an infinite numbers of stars. In that case, no matter where we look, we would expect to see a star, and since the light from these stars would have existed since eternity, it would eventually reach us. Therefore, the universe would be completely filled with light in every direction we looked. This paradox was first articulated in 1823 by German astronomer Heinrich Wilhelm Olbers. That's why it's known as Olbers Paradox. Today, however, it's no longer considered a true paradox because we know that the assumptions which gave rise to the Olbers Paradox were incorrect. However, to understand why the universe is not glowing with light, we first need to talk about the three key assumptions of Olbers Paradox. Assumptions that suggest the universe should be filled with light. These are an infinite universe, a static universe, and a timeless universe. If the universe had all three of these properties, it would be filled with light from end to end, but clearly isn't filled with light. That means the universe doesn't contain at least one of these properties. So which one or ones does the universe not have? The person who resolved Olbers paradox was Edwin Hubble in the 1920s. Hubble discovered that galaxies are moving away from each other, which means that the universe is neither static or timeless. He found that the universe is constantly expanding over time. This discovery led to the development of the Big Bang theory, which has become the most widely supported model of the universe, backed by numerous lines of evidence. According to the theory, the universe doesn't have an infinite age. Of course, the reason this discovery helped resolve the paradox, the universe is not filled with light, because not all the stars in the universe have existed since eternity. Some of them simply haven't had enough time for the light to reach us. As a result, it's impossible for the stars to fill the entire universe with light. The oldest light that has reached to the Earth has been traveling for not more than 13.82 billion years. Anything beyond that cannot reach us, because the speed of light is a universal limit that cannot be passed. This explains why the universe appears pitch black, especially when you compare that limit with the vast distance in the cosmos. However, it's also true that the universe is pitch black only right now. In the early stages of the Big Bang, the entire universe was extremely hot and dense. And just as expected, back then the universe was filled with light everywhere you look. However, as the universe expanded and cooled, the distance that light from these sources had to travel increased. In other words, the fabric of spacetime was stretching, and this expansion was stretching the light itself. Today we call this effect redshift. This light remaining from the Big Bang has been stretched so much that its wavelengths had shifted beyond the infrared range, meaning it's no longer within the visible spectrum. That's the main reason why the natural radiation from the Big Bang doesn't make the universe glow visibly. Still, one question remains: why does the fabric of spacetime itself seems black? Why isn't it green, pink or purple, but black instead? We will explore this question in another video. For the next videos, like the video and subscribe my channel. Thank you.